Hello everyone! Welcome to today's Xamarin University webinar. I'm glad you're here, and I'm really excited to be here today to talk about some of the ways that we can customize our Xamarin.Forms applications. But before we get to that, I'd like to introduce myself. My name is Rob Gibbens, and I'm an instructor and a manager for Xamarin University. Now, I'm always happy to talk to other developers, and you can contact me through Twitter, the email that you see there on the screen, or you can check out my blog. Before we get started with our webinar, I want to let you know that we have our expert trainers online right now, ready to answer your questions. So if you have any questions, please send it to us using the Q&A on the website, and we'll answer it there. I also want to point out that you are going to receive an email after the webinar with links to a recording of the webinar, along with links to all of the slides and the code that I'm going to be showing, so you can review it all later at your convenience. We've been really excited to share our webinar series this month, and we would love to have you all join us online at Xamarin University. Our team has helped thousands of developers deliver amazing native mobile apps. With Xamarin University, you get live interactive training led by our expert trainers. We have more than 80 classes. They're offered in all time zones, so you can always catch a class when it's convenient for you. You'll also be able to schedule one-on-one sessions to answer your questions, discuss architecture, remove technical roadblocks, and get guidance on your application. Xamarin University is also the way to become a Xamarin certified developer. And we now have some great flexible subscription offers too. You can get full access for less than $3 a day. And if you're building a Xamarin app, or if you have plans to, then Xamarin University should be your first stop. And when you're building a mobile app, Microsoft has you covered during the entire application lifecycle. From developing for multiple platforms, using the operating systems and IDEs that you love, to testing, continuous builds, distribution, analytics, and monitoring, we have a solution for you. Today we're going to be focusing on the build part of the lifecycle. Let's review our agenda for the day. We're going to explore some ways that Xamarin.Forms allows us to write our code in a shared, cross-platform way, while still allowing us to customize the final application's user interface. So first, we'll quickly review your options for your mobile development using Xamarin, including Xamarin.Forms. Then we're going to start with some quick customizations that you can add to your app. Then we're going to get a little bit more complex, and we're going to see what Xamarin.Forms effects and custom renderers can do for us. Finally, we'll see some of the newest options for integrating Xamarin.Forms with the native platforms. As we're going to be discussing some of the more complex bits of Xamarin.Forms, I am going to assume that everyone is at least generally familiar with Xamarin.Forms. If not, or if you're brand new to Xamarin.Forms, I definitely suggest checking out Xamarin University's free self-guided learning, where you can learn everything that you need to get started with Xamarin.Forms. Let's start out by talking about today's mobile landscape and why customizing our apps is important. Now, as a society, we've seen a massive shift in consumers' habits and interactions with technologies since the first iPhone came out 10 years ago. It's now a mobile-first, cloud-first world. And we expect our data, our important information, to be available to us wherever and whenever we want it. Smartphones have become a pervasive and a presence in all of our parts of our lives. They're rarely out of our hands for long. And most likely, we have multiple devices that we use each and every day. I currently have 7 different devices in front of me. And while we as developers might be on the extreme end of things, even our users will bounce between their phone and their desktop or laptop and their tablet throughout the day. And that list is continuing to grow. We now have wearables like watches and fitness trackers, virtual and augmented reality devices, things like HoloLens, gaming consoles, and IoT. We can probably check our email on our toasters now. This data is everywhere. So with so many choices, we as developers need to make sure that our apps not only support the devices that our customers use, but that we provide the very best experience on each platform. We want to make sure that our apps look and feel like a native part of the platform ecosystem. So great. You need to reach your users, and you know they want to use an app. So how do we go about that? Well, let's focus on the 3 big ecosystems. We have iOS, Windows, and Android. And writing apps means adding business logic and creating a UI. And for iOS, in the traditional approach, we would build our iOS app using Objective-C or Swift, and we'd use Xcode. We build our Windows app using C# and Visual Studio using the .NET library. And we build our Android app using Java in Android Studio, using the Android SDK and the Java SDK. But what we really want is the ability to write applications that can take full advantage of the power and the features and the performance of each platform, but we want to write the code in a common language. Or even better, we want to share our code across all of those platforms to reduce development time and help keep the apps synchronized across all of our supported devices. And that's where Xamarin comes in. Xamarin is an app development platform that lets you build applications for iOS, Android, and Windows, and share code across all of those platforms. And that includes things like Android phones, iPhones, iPads, Windows Mobile, but it also includes other form factors like Windows Desktop, or Mac OS Desktop, wearables, IoT, Xbox, PlayStation, Apple TV, HoloLens. We can write applications that share code across all of those device types and operating systems. With Xamarin, you write your applications in C# using Visual Studio on either Windows or Mac. And it's more than just the C# language. You also gain access to the .NET libraries that provides features and standard APIs across all those supported platforms. And with Xamarin, you have two development strategies. The first is to share your business logic and then write your UI uniquely for each platform. And that's a really powerful technique. You're able to use the exact same code for your business logic across platforms and then take advantage of the unique UI features on each platform, using the native controls and the native design patterns. This technique gives you really precise control over the UI, down to the pixel, and gives you access to every bit of the native UI toolkits on each platform. And this can still allow you to share, let's say, 70% or more of your code across Windows, iOS, and Android. There's also another option though. Xamarin.Forms allows for even more code sharing in the form of a shared UI definition. With Xamarin.Forms, you define your UI once, and that UI definition is then used to create the appropriate native controls on each platform. Now we're going to be focusing on Xamarin.Forms today, but we're going to see how we can combine these two approaches to enable us to define our UI once, share it across platforms, but still take advantage of the uniqueness of each platform. And Xamarin.Forms makes the process of creating the application easy by allowing you to define your UI once and share that definition with different platform implementations. The framework utilizes the native platform's controls to render your UI, which is great. That means that we get the native look and feel and everything looks as it should on each platform. Although, the fact that we can define the UI once really doesn't excuse us from ensuring that the app follows the platform UI paradigms and the styles, and that we really take advantage of each platform. And the Xamarin.Forms development team has tried really hard to make the app look and act reasonable on each platform, and we'll use the platform-specific paradigms properly and take advantage of the platform control capabilities where we can, but without any customization, the app tends to look and feel somewhat generic. And sometimes there are going to be small areas where it just doesn't quite look right, or where Xamarin.Forms doesn't let you influence the native control. So for example, disabled buttons on iOS change the text color, but you can't control that directly from the Xamarin.Forms APIs. So our goal here today is to quickly look at moving outside of that shared definition and to look under the hood at how Xamarin.Forms renders controls and what we can do to alter that behavior. Let's take a look at how Xamarin.Forms actually works. Now I mentioned earlier that Xamarin.Forms will take our element definition and turn it into a native control. So for example, in our shared code, we would create a Xamarin.Forms button element. You see there on the screen. This is Xamarin.Forms abstraction of a button. But at runtime, the framework will turn the shared button definition into a native Android.widget.button on Android, or a UIKit UI button on iOS, or a native Windows button on Windows. Xamarin.Forms provides a really powerful cross-platform API surface to customize our UI, but is limited, and is limited by necessity. Remember, we're targeting multiple platforms here. Xamarin.Forms can only expose the properties and the functionality that are common across the platforms. So again, here on the left, we have a partial definition for a Xamarin.Forms button. And this shared Xamarin.Forms element allows us to set some basic color properties, things like border color and text color. And those are properties that all of the supported platforms share. However, the native views have substantially more customization points. Take a look at the right at the definition of a native Android button. It has quite a few more button properties and states that aren't reachable from the Xamarin.Forms definition, like current hint color and highlight color. we can't set those properties from our shared Xamarin.Forms code because they're specific to Android and they're not common across all platforms. Fortunately, Xamarin.Forms gives us quite a few options for customizing our app's UI. These include quick changes based on the current running platform using the runtime platform API in Xamarin.Forms or platform-specific theming capabilities. We also have the ability to define our shared UI, but still tap into the powerful platform APIs using effects and custom renderers. And lastly, you're never actually locked into an architectural choice between Xamarin Native and Xamarin.Forms. You have the ability to embed platform native controls directly into your shared UI, or even create a native Xamarin iOS, Xamarin Android, or Windows UWP project, and still design individual screens using Xamarin.Forms. We're going to get into some demos for the rest of this webinar, and I'm going to show you how we can take a really simple business application and start customizing the UI to take better advantage of each individual platform. As we explore this application, I will say that this is not a lesson in beautiful design. I am not a designer by any means, but I do want to show you what Xamarin.Forms is capable of in terms of customization. Now, as a reminder, all of this code, both the starter solution and the finished project, will be available after the webinar. I'll include the link at the end of the webinar, and you'll also receive it in an email. Let's take a look at our starting application. Now, I'm using a very simple representation of a typical line of business app. So here we have the same Xamarin.Forms app. It's running on iOS, Android, and UWP. Now, this might represent a kind of app that you might have seen before. With this app, we're going to collect some information from our user, like their name and their location, and we're going to allow the user to register their device with our backend system. Obviously, this app is pretty plain, so we're going to see what we can do to add a little bit of customization to it. Now, if you take a look at the top of the iOS app, you'll see the first thing that I need to fix. My label, which is the register this device, is under the clock on the status bar. Well, that's not exactly what I want. It doesn't look very good. Notice that the Android app and the Windows app, they don't have the same problem. And this brings us to our first customization point with the Xamarin.Forms APIs. We have the ability to change properties or call different methods in our shared code based on the runtime information, including which platform the app is running on. By using the on-platform API, it's easy to change the value of any property that you set on an element in your UI based on the platform. Here, you can see an example of customizing the background color of a label. We can specify the platform, Windows, iOS, or Android, and set a value for the property when the app runs on that platform. Again, the important thing here is that we're putting this into our shared code, but we're making it execute a specific branch or return a specific value based on the platform that we're executing on at runtime. We can also customize the UI from our code behind using two properties from the static device class. The runtime platform property enables you to make decisions and modifications based on the platform. And the target idiom lets you check if the app is running on a phone, a tablet, or a desktop. Let's take a look at this in code. All right, so I'm going to go ahead and open up Visual Studio here. And let's take a look at our solution. So I have my normal 4 projects, and in our shared project, I have the main page. I'm going to open that up, and this is defining that page we just looked at. So here, notice here's my label for the register label, register this device. And this is the problem we have on iOS, is that this is too far up. It's underneath the status bar. If we come up to the content page, you can see we have a static padding that's going to stay the same for every platform, no matter what we're doing. And that's the problem, is that on Windows and on Android, that 5 units, that's going to be perfectly fine. That's going to push things in 5 units from each edge, from the left, top, right, and bottom. But for iOS, we need a little bit more. So we're going to fix that. And if you look at the branches, which is at the bottom right of Visual Studio, I have some branches. So I'm just going to switch between these branches as we go through this webinar, and you're going to have access to all of this code, including the branches, so we can flip right between them. So let's switch to the on platform. And here you can see, now I've taken the padding out of the content page, and using the on platform, lines 7 through 13, we are creating specific values for each platform. For Android, I'm going to keep that as 5, and it's going to be 5 from every edge, and the same thing with Windows. But for iOS, we're going to set that specifically for 5 units on the left, 20 from the top, so it's going to push our label down a little bit, and then 5 from the right and 5 from the bottom. And you can see here again how we can provide platform-specific values for our running code. So let's go take a look at that now on iOS and see what that looks like. And here you can see now our register this device label is pushed down. It looks a lot better, and we fixed that. And we've only fixed it on iOS where it needs to be fixed. But notice also the label. It says register this device. And it says that same thing on every platform, iOS, UWP, and Android. But we can customize that a little bit more. I'm going to switch branches again now. And notice that my label, I gave it a name, register label. If we look at the code behind here in the main page, I've now added a little bit of code using the device.runtime platform enumeration. And here we have our registered label, and we're going to change that based on the running platform. So I have a switch statement, and I'm going to do something for device.iOS, device.android, and device.windows. Let's go ahead and run that. And here we can see now our label says registered this iOS device. We're getting a little bit more specific, and we're customizing it based on the platform. And we can do that same thing, and we'll check out Android as well. And now it says register this Android tablet. And we'll run that on Windows. And as you can tell from the code, it's going to say register this Windows device. And there we have the correct label. But we can get a little bit even more customized. Let's go ahead and stop debugging, and we're going to switch to the branch 4. And now we've introduced the device.idiom. The device.idiom again allows us to check to see if we are on a phone, a tablet, or a desktop. For iOS, we're checking if it's a phone or a tablet, and we're going to change our label. Same thing with Android, and then for Windows, we're checking if it's a phone or a desktop. So I'm going to go ahead and run this on Windows first. And there you can see it's picking up the fact that I'm running this on my Windows desktop. And if we run this on an iPad, we're going to get registered this iPad. And there's our iPad simulator with the correct label. Our next option for customization is using the platform themes. And if you want to customize colors, fonts, spacing of the controls that are unique to a platform, then the first thing you should do is look at the theme capabilities of each platform. Each one ships with some ability to manage themes. And keep in mind that Xamarin.Forms has a style API as well. So if you want the app to look the same on all the different platforms, you should use the Xamarin.Forms style API. But if you want the apps to look different on each platform, we can use the theming capability. On Windows, this is encapsulated in the style and the control template API. And since Xamarin.Forms is creating native controls, you can define global styles in your app.xaml in the platform-specific Windows project, which is going to be applied to each of those native controls. And this is going to let you change the selection color, the hover effects, or even completely replace how the control is rendered by assigning a new control template with a global style. Now this is the Windows app.xaml file, not the Xamarin.Forms app.xaml file. This is Windows specific. On iOS, you can use the UI Appearance API to establish some default property values for almost all the UI view types. And you apply this in your app delegate code, and that's going to ripple through the UI definition. And this is controlling, for example, how all the UI switches in the app are going to look. And then finally, Android defines themes that can be applied to your main activity, which is used to host your forms visuals. That theme then dictates the colors, whether you have an app bar, the fonts, etc. for your application. And Android 5 defined 3 built-in themes that you can derive from, and you can create your own new themes as well. These themes can be applied at an application level or just to specific activities. And it's not a whole lot of work to create custom themes that derive from the defaults. So let's go add some themes to our application. Now the first thing that we need to do is add a navigation page so that we can navigate between our main page, and you see here I have a signature page. We have 2 different pages we're going to be navigating between, and we're going to use some themes to style that navigation bar. So let me switch to our next branch, which is the navigation page. And you can see in our app.xaml now I'm surrounding our main page with a navigation page. Again, let's take a look at that, just running on our iPhone because now we've added that. So by default, we have just a plain white navigation bar. There's no styling to that quite yet. Now I've switched to the next branch, which is our UI appearance branch. And we're going to go to the platform-specific iOS project, and we're going to look at the app delegate. So in here, I have added some appearance APIs for the UI navigation bar.appearance, and I'm changing the bar tint color and the tint color. Let's take a look at the difference that this makes now. So now we have this nice kind of Xamarin blue navigation bar, and that's only going to be applied on the iOS devices because it's iOS specific. And that's going to apply to every navigation bar that we have in our application. It's a application-wide setting. Let's go take a look at Android. So we'll run this first just to remind ourselves of what it looks like. All right, so there we just have kind of a light blue navigation bar, and that's coming from just the default styles in Android. We'll switch to our next branch here, this Android styles one. And now let's go look at the Android project. Here, we've added another folder under our resources folder called values-v21. And in there, we've added a styles.xml file. Let's go ahead and open that up and look at this. This is our XML file that's going to define our styles. And notice I gave this style a name of my custom theme. And I've defined some colors using just hex codes. And then I'm defining things like the color background and the navigation bar color. And then some text color as well. I'm setting to black. And then if we switch to our next branch here for this main activity, and we take a look at the main activity code, in the activity attribute in our main activity, and again, this is all in the Android project, I'm setting the theme specifically to our My Custom Theme. That's the one we just created. Let's take a look at the effect that this has on our app. And now you can see that we have this kind of gray navigation bar up there. So I've changed and customized the colors for the navigation bar there. And I could do that same thing for labels and buttons and all kinds of stuff in Android, and we can make it look really great. And Android has lots of really good material design documentation to kind of help you design and create these really beautiful applications. Now let's check out Windows. So for Windows here, we kind of have a really light gray navigation bar up at the top, or title bar. We'll switch branches, and then we'll check out the Windows-specific styles that we've created. Now in Windows, these styles are going to be located in the app.xaml file. And here I'm just setting the text block, and I'm changing our labels and our text to be a little bit bigger and a dark blue color. And now our register this Windows desktop label is that kind of dark blue and it's a little bit bigger. And that's going to apply to every label in the system as well. And here you can see how we can customize the different platforms, and we don't always have to customize the same things and make things look the same across all the different platforms. For Windows, I changed the label, and for iOS and Android, I'm changing the navigation bar. And you have a wide range or wide power to be able to customize and apply these themes across the entire application. Now, the theme APIs let us tweak colors and other properties, but the capabilities change from platform to platform, and for the most part, that's a global setting. So the theme can't be applied just to one element, for example, and just one label on one screen. However, we have another trick up our sleeve that turns out to be much more powerful and much more selective, and that's effects. The Effects API allows you to attach to the native control and the renderer and make changes to the control's visual properties. Effects can be applied to individual elements, or even to groups of elements using the Xamarin.Forms styles. You'll most commonly use this to adjust visual things, but it's actually capable of quite a bit more. Because the effect is this intermediary object that knows about and has access to the native control, and to the renderer, and to the Xamarin.Forms element, it can even inject new features. It can handle event notifications and methods that the default renderer doesn't, or even adding new native visual elements onto the screen. This is a very powerful API. Let's take a quick look at how it works. So what exactly is this effect? Well, it is a platform-specific class that resides in the platform-specific project. It can use the native APIs because it's in the platform project, and it can use those to change the appearance and the behavior of the native control that's created by the Xamarin.Forms renderer. Remember our picture of how the rendering system works. We have a Xamarin.Forms element, in this case a button, that represents our control in the shared code. And then we have a renderer on each platform that takes the element and creates a native control. Well, the Effects API adds to this picture a little bit. The renderer will create the native button and pass it over to the effect. The effect then can examine that created native button and make changes to it. Now, it can't change the button or replace the button, and it can't force a different renderer to be used, but it can do almost anything else to it. So in this example here, we can adjust the layer properties in iOS to generate this nice semi-transparent blurred drop shadow, which becomes our actual rendered visual on the screen. And that's something that we can't do just in the shared Xamarin.Forms APIs. When creating an effect, you're going to need to create an effect for each platform that you want to support. And each class might be implemented differently depending on those available platform APIs. Also, keep in mind that not every platform has all the same features. It's very possible that one platform might be able to provide a specific effect that another platform can't. And that's okay. If you don't have an effect applied on a specific platform, Xamarin.Forms will just default to its regular values. So how do we actually apply an effect to an element? And there's actually two different ways. The simplest way is just to create an effect using the static effect.resolve API, where you're going to pass in the unique effect identifier. That would be the myCompany.shadow effect here in this case. To apply the effect, just add it to the element's effects collection. Every element in Xamarin.Forms now has an effects collection that you can add to. The second option is to create a custom implementation of a class that derives from Xamarin.Forms routing effect class. The routing effect class has a constructor that accepts a string. This string is that unique ID, effect ID. Under the hood, the routing effect will resolve that effect when it's instantiated. This lets you keep that string-based effect identifier in one place, which makes it less likely to mistype. Using a routing effect also lets you add effects directly in your XAML. And then the final step that we have to do is associate our name and our unique key that we're using to identify the effect with the effect itself. This is actually a two-part process. The effect.resolve method expects two parts to the effect name, separated by a dot. There's the group name, and this is most commonly going to be your company name for that part, and then there's the effect name, which is the unique effect name. Those two parts are then defined in each platform assembly through some assembly level attributes. The resolution group name, that identifies the first part, that's the company name. And that's prepended on every exported effect in the entire assembly, so you only need that once per project. The export effect attribute identifies the effect name itself, and you'll need one of those for each effect. And notice how it's identifying the effect name and the type of the effect. That's how it's going to find the actual code to execute. So let's add an effect to our application. So effects are very powerful. They give you access to the underlying native APIs, and you can do a lot of different things with them. In our case, we're going to add an underline effect to our label. So we'll switch branches here, and the first thing that we need to do is we need to create our effect, and we're going to do that in our shared code. So here we've created a class called underline effect, and it's going to derive from the routing effect base class in Xamarin.Forms. Now, as you can see, there isn't any actual code in here besides just the constructor. And right now we're passing just an empty string to that base constructor, but we're going to change that soon. Then we can go over to Android, and let's take a look at the actual implementation for Android. So here, the underline effect, we're going to derive from the platform effect in Xamarin.Forms. And we have a couple overrides here, so onAttached and onDetached. OnAttached, we're going to call the add underline. In the add underline method, we have our control. And this control is going to be the actual native Android control. That's going to be a text view, so we'll cast that to a text view, which is what our label is in Xamarin.Forms. And from there, we can use some Android APIs like the paint flags, and we can say underline text. For iOS, we can do the same thing. So here in iOS, we have the iOS underline effect, also deriving from platform effect. And in our add underline here, our control is going to be cast to the UI label. That's the native control in iOS. And here, again, we're using the iOS specific APIs. So we can say the NS mutable attributed string, and we can put an underline under there. And finally, in UWP, as you might imagine, we also have a Windows underline effect. And in this case, our control is going to be cast to a text block. And with a text block, we can then create an actual underline class, a new run class, and we can add that underline into our application. The next thing we need to do is we need to wire up the unique identifier. And we're going to do that using the resolution group name and the export effect. We'll put these attributes on each one of our underline effects. So we have the resolution group name, and we're going to put that to our company name, so Xamarin, and export effect, and we're telling it which type we're going to use. In this case, UWP underline effect. But then notice the name is just underline effect. And if I look at iOS, we have the resolution group name there as well, with an export effect, giving it the correct type, and still that same name, underline effect. And Android is the same. That combination of the resolution group name and the export name, that's going to be our unique key that we can use to access this. So now what we need to do is actually add this effect to our label that's in our UI. Let's go back to our shared code and open up the main page. And the first thing we want to do is we want to make sure that we have our namespace declared. And that's going to be customizing Xamarin.Forms. And if we come down to the label, we're adding our unique effect, our underline effect, to the label.effects collection. And we're using that namespace, customizing Xamarin.Forms, and we'll use the underline effect. And the way that that is getting wired up is, if we look at the underline effect, if you remember when we first created this, our string that we're passing to the base constructor was an empty string. But now we're going to pass in the Xamarin.underline effect. That's the resolution group name and the export name. Those are going to get tied together, and that's how we're going to be able to find the correct effect on each platform. And let's go ahead and run this. And now our label has an underline. All right, so let's try iOS next. And now the register of this iPhone is underlined there. And lastly, of course, we'll try Android. And there we have our underline applied on this platform also. Now sometimes you might want to communicate between this shared code underline effect and the platform specific effects that you are applying to the UI. And we can do that as well. Let's change branches again. And now if we go to the actual platform specific projects, we can see that we now have a new override, and that's the onElement property changed. And this is going to respond to notifications about the iNotify property changed interface, just like data binding does. So anytime we change that, anytime we change a property on the underline label, we are going to get this event, and we will respond and we'll re-add our underline. So let's change branches one more time. And now in our shared code, I've added this save on clicked method. And anytime we click the save button, we're going to change the text color to just a random color. Let's see what that looks like. All right, so right now our label is black, but if I click the save button, we are setting a property on the label, which is our shared label. The notification change is getting raised, and our effect is listening to that and changing it to just a different color based on whatever we set. And effects are great because they let you tweak existing controls. But what if the control that you want to display simply doesn't exist in the Xamarin.Forms API set? Once you get outside of the typical elements like labels, buttons, and images, that becomes fairly common. So remember, when we add a Xamarin.Forms control to our shared UI, Xamarin.Forms will take our element definition and turn it into a native control. So for example, our button element would turn it into an Android.widget.button on Android or a UI button on iOS. And the code that does that is called a platform render. Every element that you work with in Xamarin.Forms has a unique renderer assigned to it that takes your element instance and creates a unique platform-specific native control to represent it on the screen. And those renderers are, by nature, platform-specific. So you can see here we have a unique renderer object defined for each of our supported platforms. We're showing 3 here, but there are also renderers specific for Windows Phone and Windows Desktop, and as soon as Xamarin.Forms supports Xamarin Mac, we'll have a renderer there as well. And Xamarin.Forms includes a renderer for each visual element on each supported platform. You can see a small selection of those renderers here. There's also a complete list of these renderers on developer.xamarin.com, or you could just go check out the GitHub source for Xamarin.Forms and take a look at them there. So those renderers in Xamarin.Forms is great, but it doesn't include every possible control type. Depending on the complexity of your UI, you might reach the limits of Xamarin.Forms elements and then decide to define your own. Maybe something like this speedometer gauge here. This doesn't have any built-in control that we could just simply use. We're going to have to create our own renderer for that. And there's other things like reporting that you would need to do as well, and graphing. There's a few different steps that we need to complete to create and apply a customized renderer. First, we'll need to subclass the Xamarin.Forms element to create a unique element. We'll subclass the platform-specific renderers and adjust the properties on the native control. And we need to export the renderer so that the custom renderer is used for our derived element. Keep in mind, steps 2 and 3 here, those are platform-specific, so they need to be repeated on every platform that you want to support. So we'll start by defining a new element in our shared code. Since this gauge example doesn't really fit any of the existing elements, we need to derive from the base view class in Xamarin.Forms. The next step is to create our renderer on each platform. Since our element derives from the base view class, our renderer will derive from the view renderer. Notice the nice straightforward naming convention here. The view renderer is generic. We need to specify our Xamarin.Forms view derived type That's going to be the myGauge view. And the native view that's going to actually represent the element. This is going to be a custom view. And then specifying the view type here makes the renderer's control property strongly typed, which is going to simplify reaching the native view's properties and methods in the render. And again, we're going to assign the renderer's native control here in the onElementChanged method of our custom render. When we're deriving from the view renderer, which is what we're doing here, we're going to explicitly set the native control to be this gauge view. Now, this gauge view is the actual graphical drawing of the gauge on the screen. So we'll instantiate that control, and then we assign it using the setNativeControl method. And the last step is to associate the renderer with the element that's defined in the shared code. To do this, we're going to use the export renderer assembly level attribute. This is commonly defined above the platform-specific renderer. This is what maps the renderer to the shared element. And the first parameter here is the shared element type, myGaugeView, and the second is the type of the platform-specific renderer. This is the only way to associate a renderer with a Xamarin.Forms element. If this is missing, your custom renderer won't be used and the custom control just won't show on the screen. So now we're going to add a custom render to our application. All right, so let's take a look at the application that we have. I mentioned earlier that we have multiple pages in the application. And if you see down here, we have a button that says Sign Document. Again, as a typical business application, this is something that you might want to allow people to do. If they're going to register their device, they might want to sign the document to verify that they actually own the device. So if we click Sign Document, we're going to go to the second page. Now, right now, all we have is simply just a Sign Here entry box. Now, this would be a lot better if we could provide an actual surface that the users could sign their name on using their finger, and they could actually draw their name. All right, so we've switched branches now, and we have a new file in our shared code. This is our sketch view. We want to actually sketch our name. Notice that this just derives from the base view class. We could also create custom renders for a base button or a base label or entry control, but in this case, there isn't really anything that's going to supply us the drawable surface that we want besides just a view. And notice we also have a bindable property for the ink color. We're going to allow the user to actually click a button and change the ink color. So we'll get some notifications and some communication back and forth between the different layers of this custom render. So this is just our base class, and this is what we can use in Xamarin.Forms. But again, we need custom renderers for each platform. So if we take a look at Android, we'll start there, and we have a sketch view renderer there. We're going to open that up and notice that our sketch view renderer is deriving from the base view renderer class, and it's going to take in a type of sketch view. So that's the shared class that we just created in our shared code, and then also this paint view class. And notice the paint view class is defined here in Android. We'll take a look at that real quick. This paint view class, notice, just derives from Android.views.view. And we're going to use a whole bunch of Android APIs to actually draw on our canvas on our screen. But the thing to notice about this class is it doesn't have any dependencies at all on Xamarin.Forms. This is just an Android view, which means even outside of Xamarin.Forms, you could use this same control to provide a drawable surface in a Xamarin Android application. You could put it right into your AXML files. Let's go back to the renderer. And in the renderer, we have a few overridden methods, including onElementChanged. So there we're going to take a look at the control, and the control is going to be our paint view. And as long as we have one of those, we're going to, or as long as we don't have one of those, we're going to create a new paint view, and then we'll set our ink color to whatever is on our element. Now this element is our sketch view. This is the shared element that is in our shared code, and all of our platforms have access to that element. And then we're going to call the setNativeControl, and we're going to pass it in the paint view. That is going to then draw that on the screen. We also have an onElement property changed, so anytime we change that bindable property that is in our sketch view, we're going to get the notification here, and we'll be able to respond to that and set the ink color. The other thing we need to do is we need to make sure that we export this render, and we're going to do that with the export render attribute. It takes in the type of our shared control, which is our sketch view, and the platform specific type, which is our sketch view render. And notice this attribute has to be outside of the namespace. This is an assembly level attribute. And if we take a look in iOS, again, we have the same pattern going on here. We have our sketch view render that derives from view render, and we have a paint view class. If we take a look at the paint view class, in this case, this is going to derive from a UI image view. And we'll use all the iOS native APIs to set the ink color, to clear it, to draw the line. So we're going to use the UI graphics API to draw on iOS. And again, the same platform is going to go on here in UWP. We'll have our sketch view render, and we'll have a paint view. And for UWP, we're going to use the ink presenter API and be able to draw on the screen there using the ink drawing attributes. Let's see what this looks like, and we'll start with iOS. All right, so now we're going to go to the next page with a signed document. And here, we can actually draw on the screen with our name. Let's see that in action on the other platforms as well. So there's Windows, we can draw on there. And of course, we'll be able to do the same on Android. So here, we can draw on Android also. So you can see how custom renders are extremely powerful. We get to create our own controls. We're not just locked into what Xamarin.Forms ships out of the box. Xamarin.Forms tries its very best to provide us most of the common controls, but not everything. Custom renders let us outside of that constraint of what Xamarin.Forms provides. So now we've seen how we can customize the controls that are included with Xamarin.Forms by altering runtime values, adding effects, or taking over the entire rendering process. But what if we want to use a control that Xamarin.Forms just doesn't include? Each mobile platform provides this rich selection of native controls. And when we create a Xamarin.Forms app, remember, it's those native controls that are actually presenting our UI. And that's going to include all the common things like buttons and labels. But the native platforms also include more specialized controls. And it's often these specialized controls that can really help make an app stand out or feel more integrated. Take a look at this toolbox image here for an Android app. These are just some of the native controls that are available to Android developers. However, we also saw that Xamarin.Forms only exposes the most commonly used control types that are available on all of those supported platforms. And that means that many of the native controls are not reachable using the API surface provided by Xamarin.Forms. But there is some good news. Xamarin includes a feature that allows native controls on each platform to be added directly into a Xamarin.Forms UI. And that makes it really easy to bring in unique controls on a specific platform, like the iOS segmented control that you see here. And we can add it to our Xamarin.Forms layout. This gives us the best of both worlds. We get the shared UI and the rapid development of Xamarin.Forms, combined with the ability to take advantage of the native UI toolkits when necessary. So here's an example of how we can add a native control into our code. We're creating an iOS detail disclosure button. Again, this is a fully native control. It's on the iOS platform, but it's not available from Xamarin.Forms. And this code here could be either placed in the iOS head project, or if you're using shared projects like we are in our demo, then you can include this code with some compiler directives and then include it in your shared UI definition. Once we create that native control, we are then going to call Xamarin.Forms toView extension method. This is going to return us a Xamarin.Forms view class. And that returned Xamarin.Forms view can then be assigned to the content property of this content view, or we can assign it on a content page. We can embed it into our shared UI. So let's go customize our application a little bit more. Now let's go back to our application here. And we're going to go back to the main page. You see here we have some entry controls for name, street, city, state. And we also have a drop down. This is a picker in Xamarin.Forms. And I'm going to pick a gender, so female, male, other, not specified. And we've got this sign document button in order to sign this. We can customize that a little bit more though. Let's go ahead and change our branches. All right, and now we're going to look back at our main page in our shared project. So again, here I just have a picker control that is going to have the gender in it. But if we look at the code behind for our main page, I've now added a few methods. So add native Android controls, add native iOS controls, and add native Windows controls. If we look here, we're in a shared project. So I'm able to set the context, and in this case it's Android. And then I'm surrounding my code in a compiler directive. So I'm saying if this is Android, and only on the Android platform, I'm going to be able to do things like create a radio group. This is a native Android UI element. And we can set all the different properties on it. And then we'll create some radio buttons for female. We can call the set text color, things like that. And then here on line 108, I'm actually going to call this toView extension method and pass in the radio group. This is going to return a Xamarin.Forms view. And we've already seen the view before. And then I have a little bit of code here to remove the picker that's already on our screen, and instead we're going to add that view. And then after that, I'm also going to create a floating action button on Android. Floating action buttons are a part of material design, and they're meant for the main action that you're going to take on a specific screen. We can add one of those in there. We can wire up the click event, and in this case, we're going to create a floating action button to sign our document or sign our registration. So we'll just use the navigation, we'll push to the new signature page. And again, we'll use the toView extension method to get us a Xamarin.Forms view. And once we have a Xamarin.Forms view, notice we can call Xamarin.Forms properties like horizontal options and vertical options, and we can add it to our main layout, and that's a Xamarin.Forms control. And if I switch my context to iOS, you see here we are going to use a UI segmented control. That's in the UI kit namespace. That is a iOS specific native control. We'll insert some segments, and then again we're going to call that toView extension method that will get us our view back. We'll remove the picker and then add the segmented control instead. And then for Windows, we'll just create some radio buttons. And we'll get that toView extension method. That's going to get us a view back. And now we're going to create a stack layout. That's a Xamarin.Forms layout. And we'll add our different radio buttons. We're going to make this horizontal. So let's go ahead and run this on Android first. And here on Android now, you can see we've pretty dramatically altered the look and the feel and the UI of our application. Now we have radio buttons instead of having a picker. And we have our floating action button down here with a little pencil because we're going to be signing our page. So we can click that and we get our signature page. Let's run that on iOS. And now on iOS, we have the segmented control there to pick our gender. And lastly, we'll run it on Windows. And for Windows, we have our radio buttons again. So let's compare these now. So now you can see we're starting to customize our shared UI for each platform. And they're starting to look a little bit different. And we can have that kind of customization per platform. We can make these stand out and really integrate with the native platforms by using things like the native controls. Finally, let's take a look at a recent addition to the Xamarin.Forms framework. And that's the ability to embed Xamarin.Forms pages into a native Xamarin application. Now, as we've seen, Xamarin.Forms is great, and it enables us to write some really fantastic cross-platform apps. It's not always the right choice, though. There are many reasons why you might want to create your applications using Xamarin iOS, Xamarin Android, and Windows UWP natively. That might be for performance, for pixel-perfect control of the UI, deep integration with the native platforms, or because you have completely different user experiences on each platform. And while you can do these things using Xamarin.Forms, sometimes it's just easier using the native design tools. Well, Xamarin.Forms 3.0, which is currently in pre-release, includes the ability to create a shared Xamarin.Forms page in your shared code, and then instantiate that page and navigate to it from your native UI. And this is really great if you have a highly customized app, but you also have a few screens that should look the same on all the platforms. Maybe it's just a simple list view, or a data collection screen, or just a settings screen. Well, Xamarin.Forms 3.0 includes platform-specific extension methods that create the native UI element for each platform. For Android, that's going to be a fragment. Once we create the fragment, we use Android's fragment manager to swap the content of an activity. On iOS, the createViewController method will return a native UI view controller, which we can then navigate to. And Windows UWP projects will create a framework element. Because this is still in pre-release, the Windows support is still under development. We're going to switch demos now and open a solution with 3 native projects. So let me switch my Visual Studio, and now we have this other solution that is really just a file new solution for the cross-platform template. And this created a native iOS, a native Android, and a native UWP project in our solution, along with a portable class library, which is where I can add my shared code. And the first thing you might notice here is I have a storyboard for my iOS project. Again, this is a native iOS project. I can use all the iOS design tools like storyboards and zip files, and we can use the toolbox, and we have a designer where we can drag and drop our controls onto the screen, which we don't have with Xamarin.Forms. And then in Android, you see I have an AXML file. I have my activities. I have fragments. I have all of the native controls in Android that you would expect, and all the power to tap into the entire platform. But then if you look at my shared code, I also have a XAML page. This XAML page is a Xamarin.Forms page. In this case, this is going to just show us a list of registered devices, kind of building on that registered device sample that we were just talking about. And in this case, this list view that we're going to be displaying on the screen, this is pretty simple. And this is something that doesn't need all the native APIs. It's going to look the same, and it's going to work the same on all the different platforms. And you can see I've even created a view model where we have iNotifyPropertyChange. We can use data binding. We get all the power of Xamarin.Forms. So again, we get to take the best parts of both development approaches and combine them here. And then if we look in iOS at the view controller, this is the code behind for our view controller on our storyboard. I have a button on my storyboard, and when we click on that and we tap on that, we get the touch up inside event here. I'm going to instantiate a new registered devices page. That is my shared Xamarin.Forms definition for this page. And then I'll create a new UI view controller by using the extension method createViewController. Once I have that, I can do whatever I normally would do with a UI view controller in an iOS project, including pushing it onto my navigation stack. Android is a little bit different because in order to show this second page, I needed to create a new activity, this registered devices activity. And this is AXML, and it just has a single frame layout in there. That's going to be where I swap my fragment in and out. And if we look at the main activity, when I click that button that's on my main activity, I'm going to do the start activity method, which is how we navigate in Android. And I'm going to tell it this type of registered devices activity. Again, this is in the Android project. But if I go to the registered devices activity code, here we're calling the forms init, which we have to do on every platform still to initialize Xamarin.Forms. And then I'm going to instantiate a new registered devices page. Again, that's my shared XAML page. And then we call the create fragment. That's going to create a fragment, and then we'll use just Android's fragment manager in order to begin that transaction and replace the frame layout that's on my activity. Let's run this, and we'll run this on iOS first. All right, so here is our start page for iOS. And again, this is just what came in the template, but I have my button. Go ahead and tap that button. And now it's bringing back this Xamarin.Forms list view. And I could customize this, and I could put all kinds of styles and everything else we were talking about. We could use effects or custom renders, whatever we wanted to here for Xamarin.Forms. And we can see that same shared page when we run it on Android also. All right, so here's my main activity with our button. We'll click that, and we're going to navigate to the next screen, which is our list view, shared list view, and that's shared between all of our platforms. So as you can see, this is a really powerful technique, and it's just in its beginnings. It is in pre-release. Keep an eye on the Xamarin.Forms roadmap in our forums and watch the releases as they come out and see what is getting added to this. But with this, we can really kind of blur the lines between our architectural choices between native Xamarin applications and Xamarin.Forms applications. And we get to pick which one fits our application best, but without being tied to that architectural choice, we can mix and match them. We've now seen how we can create a cross-platform application and take advantage of all the benefits that Xamarin.Forms gives us. We can design and develop the user interface once, and we can share the majority of our code. But we also saw that the power of Xamarin.Forms doesn't stop there. Using built-in APIs, such as effects, custom renders, and native embedding, we can customize our apps and truly tap into the underlying power of the native platforms. We've really just skimmed the surface of what's possible with Xamarin.Forms. At Xamarin University, we have over 6 hours of learning just on the customization options in Forms, along with over 70 other classes designed to take you from beginner to mobile developer. You can sign up for Xamarin University from the Visual Studio Marketplace, which offers very affordable monthly payment options and the ability to use your Azure subscriptions. You'll receive unlimited access to constantly updated curriculum with topics like C# for beginners and classes on the latest navigation styles and controls for Android and iOS. You can also start a free Xamarin University trial today. Xamarin University trials include access to self-guided learning, which is going to help you learn at your own pace, lightning lectures and guest lectures covering the latest in technologies from industry experts, and 2 live expert-led introductory classes, which also count towards your Xamarin Mobile Developer Certification. And I hope to see you in class. Now I want to leave you with some links to some resources to use after the webinar. If you're interested in exploring the code that we walked through today, you can access that from my GitHub account, and you can get a link to that right there at that link. While that brings us to the end of our webinar on customizing Xamarin.Forms, I want to remind you that our Xamarin University experts are going to stay online and answer any questions that you might have. Now I want to really thank you for attending this Xamarin University webinar. Again, my name is Rob Gibbens, and please feel free to contact me if you have any questions.